Hello everyone. In this episode of Drawing Lewis Structures, we're going to be drawing the Lewis structure for NO2-, which, if you note, has a charge, so it is called nitrite ion. It is not called nitrogen dioxide or anything like that. Because it has a charge, it follows the ion naming rules. And because it has one less oxygen than nitrate, it is called the nitrite ion. Okay, so this is our first ion that we're drawing. Alright, now the steps are the same, with one little wrinkle at the beginning and one little wrinkle at the end. So the first step is to sum the valence electrons that we have available. So according to the periodic table, you can find out how many valence electrons each one of those has. Take a moment and go check your periodic table. Pause the video if you'd like. And if you found that nitrogen has 5 valence electrons and oxygen has, oops, that's not a 6, the 6 valence electrons that are there, we're going to multiply that by 2 because there's 2 oxygens. But here's the wrinkle. Now it says in step 1, if the molecule is an anion, which this is, you would add an electron to the total for each negative charge. So it's like nitrogen and 2 oxygens got together, made a molecule, picked up an extra electron along the way, and so now we have an extra electron to deal with. So now our total is 12 plus 5 plus 1 is 18 valence electrons. Okay? So then, we continue on with our steps. So if this molecule were a cation, like for example a +1 charge, I would subtract an electron from the total for each positive charge. But you would, most polyatomic ions are anions, so you usually end up adding. Okay, the next step is the same. Let's add nitrogen in the middle, oxygens to the sides. You could again go up and down or whichever way you want. Step 3 says fill out the octets of the outermost atoms. Now I've used up 16 electrons. I'm counting them quicker now. And I have 2 more to go, and step 4 says any remaining electrons go on the central atom in a pair. And once again we get to this situation where we have to scan over the molecule, and we find that oxygens have their octets, but nitrogen is still short a couple of electrons. It has 2, 4, 6, but not 8. So again, we need to do the double bonding ritual of getting rid of an oxygen or a pair of electrons on the oxygens. We'll move them in toward the middle and make a double bond. That way this set of electrons can account for both of the elements involved. Now, just like our selenium dioxide example, I could have just as easily done the double bond on this side, and both would be correct. Make sure we got that. So either one of those would work. If you were ever asked to draw any resonance structures, you would actually draw both because they both do exist in oscillation with each other. Now the last little wrinkle is that if it is an ion, we see up here that it has a charge, but down here it's kind of difficult to note, just like without counting the electrons, whether it has a charge or not. So typically ions, not neutral molecules, but ions, are put in brackets with their charge attached to them. So anytime you draw the Lewis structure for an ion, put brackets around it and give the charge on the outside, and that immediately tells the viewer right away, oh, there's an extra electron somewhere in this molecule that was used to make this molecule.